Hi, I'm Miss Hearn. Let's get started. In this video, we're going to use a method I like to call the cash drawer method for converting from decimal numbers to numbers and other bases. So if you've watched my previous videos, we saw how a cash drawer could be used to write the expanded form of a number, how it could be visualized using a cash drawer like from a grocery store. And we're going to continue with that idea. We're going to think of the face values as being the number of bills we need in the cash drawer, and we're going to think of the place values as being the denominations of those bills. Unlike a normal grocery store cash drawer, though, in this problem it says draw a base 6 cash drawer. What does that mean? So in a normal grocery store, we would have denominations of $1, $5, $10, $20, the typical denominations you see in bills. But in a base 6 cash drawer, all of the denominations will be powers of 6. And we're going to have to make those denominations at least as big as the number that we're given, because we're going to imagine that this number that we're being given, which by the way, when there is no base indicated, we assume it's a decimal number, a base 10 number like we normally have. We're going to think of this as being the change we're going to give someone out of that cash drawer, and we want to use as few bills as possible. So let's start listing the bills. I'm going to draw off to the side a cash drawer. I'm going to make 2 rows because it's easier to list the powers first, and then we evaluate those powers as needed. Here's what I mean. So in my cash drawer, I'm going to have a slot. By the way, we always start on the right with a power of 0. That gives us our $1 bill, which every cash drawer has to have a $1 bill. So we're going to have, in this case, 6 to the 0. That gives us our $1 bill. But then the next would be 6 to the first, and then 6 squared, and then 6 cubed, and then 6 to the fourth, 6 to the fifth, and we could go farther, but let's see how big these bills are at this point. So 6 to the first would be a $6 bill. 6 squared would be a $36 bill. Remember, we need to give someone $43. So you want to make sure to go past 43 just so that we know we have more than what we need. So what is 6 to the third power going to be? 6 to the third is 216, which is bigger than we need. Okay, this is bigger than 43. What that tells me is that I can use bills smaller than that, the $36 bill, the $6 bill, and the $1 bill, in order to give the change that I need to give. The next thing after you draw your cash drawer is you go to the first value less than 43. So the first value less than 43 is going to be 36. And then you ask yourself, how many $36 bills can we give? So we can give 1 of the $36 bills. Okay, if we did that, then we now owe how much change? Well, we need to give $43 and change. We would give them the $36 bill. 43 minus 36 is going to leave 7. So we still owe $7 more dollars. Next to 36, which we've already used, we see a 6. That's the next smaller value, which is less than 7. In fact, we can only give 1 $6 bill because 2 $6 bills would be 12. So we're going to give 1 of the $6 bills. And of course, at this point, we had owed 7. So now what do we owe? We owe 7 minus 6 equals just 1. So that means that we can then give 1 of the $1 bills. Now, a shorter way, this isn't how I would write it out in on my paper. I would do this shorter. What I would do is here, these would be the values of the bills. These are the denominations. In other words, these are the place values that we're working with in our base 6 number system. And then I'm going to make another row below it. These are going to be my the number of bills. In other words, these are going to be my face values. So what did we say? We said we were going to give one of the $36 bills. That gave us $36 plus one of the $6 bills. So one of these, that's going to add up to $42 so far. And then we're also going to give one of the $1 bills. So that adds up to the 43. And what this tells me is that 43 base 10 is the same as 111 in base 6. Writing a number in base 6 is like telling how many of each kind of bill you would give in a base 6 cash drawer. Okay, let's try another one. Let's look at number 11, or sorry, part B, which is the number 11. Okay, again, we're just going to draw our cash drawer with powers of 6. Remember, this is 11 base 10. We want to know that's equal to what? Base 6. So that's what tells me I need to have powers of 6 for my denominations in the cash drawer. But how high up do we need to go? We have 1, we have 6, 6 to the second power is 36. This is already bigger than 11. So I can stop there, okay? And it's too big, in fact. So we're gonna go down the first bill we can give. We can't give somebody a $36 bill. Remember, these are the denominations. That's the number that's on the dollar bill. This is also our place values if we're working in a base 6 number system. The first one we can use is the 6. And remember, we need a total of 11. So 11 minus 6 leaves 5 left over that we still owe. All right, so we're going to give one of the $6 bill, but we still owe $5. The only other smaller dollar bill is the $1 bill. We're going to need 5 of those to get the $5. So what we see here is that 11 base 10 is the same as 15 in base 6. All right, let's try a bigger number, 1030. Okay, so I'm gonna have some higher powers here. Let's see how high we have to go. Remember, we're starting all the way over on the right with the 6 to the 0, which is 1. We need 6 to the 1, which is 6. We need 6 squared, which is 36. That's not big enough. We need to pass 1030 just so that we know we have what we need. So 6 to the 3rd power is 216. Still not bigger than 1030. What would 6 to the 4th power be? That's going to be 1296. Okay, that's bigger than 1030. We can't give anyone a $1,296 bill because we only owe them $1,030. So we're going to move to the next larger value, next largest value. This is the next smaller value actually than 1,030, which is 216. Now, how can we figure out how many $216 bills we're going to need? So we have a little bit of arithmetic to do. What is 1,030 divided by 216? And by the way, we don't want this in decimal form. If you just put this directly in your calculator, this is going to give you 4.768, etc. Which is helpful. This means that 216 goes into 1,034 times. But I'd rather know what the remainder is that's left over so I know how much I still owe. So I'm going to put 4. I know I need 4 of these $216 bills. But in remainder form, and in my class we talked about how you could multiply the decimal part, the 0.678, etc., by the divisor, which was 216, and get the remainder. Or there's other ways to do it, but this is 4 with a remainder of 166. That means that we still owe $166 after giving 4 of these $216 bills. So now we need to figure out how many of these $36 bills we need. So what's left, 166, we need to get as many $36 bills as we can. So that's going to be a 4 with a remainder of 22. So after giving 4 of these $36 bills, we're gonna need to still pay, we're gonna still owe $22. We're gonna still owe $22, so we're gonna have to move on to the next larger bill, the next smaller bill rather. So we're going to need to say, okay, well, how many $6 bills do I need to give to get up to 22? In other words, what's 22 divided by 6? So that's going to be 3 with a remainder of 4. So we're going to give 3 $6 bills, and we're still going to owe $4, but look, that's exactly how many single dollar bills we're going to need to get the total. Okay, so it turns out that 1030 in base 10 is the same as 4434 in base 6. Now, if you wanted to confirm that, you could actually work out the expanded form of this number. We're saying 4 times 216 plus 4 times 36 plus 3 of these $6 bills, so 3 times 6, plus 4 of these $1 bills. If you work that out, you'll see it does add up to 1030, and so that's the amount of change that we get. I hope you found this video helpful. If you did, please give it a thumbs up. That will help other students to find the video, and you can also subscribe to my channel, Miss Hearn Mathematics, for more math videos.